Hello everyone, welcome to my presentation. My name is Ridma Rathnagoda Baranaduge. Today I'll be sharing my work on classifying penguin species using Palmer Penguin dataset. To give you an overview about the dataset, I have used the famous dataset called Palmer Penguin dataset, which contains data about three penguin species, namely chinstrap, gentoo, and Adelie. This dataset includes essential features of those species of penguins, such as culmen length, culmen depth, flipper length, body mass, gender, islands they live in. Using these features, my main objective was to build a model that can accurately predict these penguin species based on their physical measurements. So, in order to predict this, I have two main points that I have considered as my hypothesis. Point one, physical measurements like culmen depth and culmen length are significantly different among these three species. Specifically, I expect that each species will have distinct average values for both these measurements. So this allows me to differentiate between the species based on their features. Point 2, I believe there is a positive correlation between flipper length and body mass in these penguins. So I anticipate that penguins with longer flipper will have higher body mass, as the additional wing surface area may contribute to improve their swimming efficiency. So this lead to great body mass supporting this adaptation. So by exploring these relationships, I aim to determine if there is any consistent pattern present between flipper length and body mass across different penguin species. I have taken as the base for this hypothesis. Uh, Without further ado, I would like to show you some interesting statistics that I have gained from this dataset. In order to give you a clear idea, I will show you the correlation between these features. There are positive and negative correlations present in this dataset. So you can see culmen length with culmen depth is having a strong negative correlation, and culmen length with body mass is showing some positive correlation, where flipper length and body mass shows a strong positive correlation. So this is the correlation between features. Moving on, I would like to show you another stat mean value for these species with the features. I have mainly observed that Adelie penguins have shortest average of culmen length, where chinstrap and gentoo penguins have longest and intermediate length, approximately 48 to 47. Moving on, in order to give you an idea about the distribution of these features, it shows us a normal distribution with some slightly skewed uh, distribution. So moving on, the EDAs that I have conducted, we can see there are several features highlighted in these species. In order to give you a more clear idea, I'll use this multivariance analysis that I have used against different combination of these measurements. You can see when we draw a plot using body mass and flipper length for these species, we can see uh, there are similarities between these species, like Adelie and chinstrap penguins have a lower distribution in this plot, where Gentoo penguins stand out with these two species. And when it's come to the body mass versus culmen length, we can see the different distribution of the plot. And also, when it's come to the culmen length, Adelie penguins have the lower distribution in the plot, and where other two penguins have the similar distribution. Let's move on to the demonstration of my machine learning implementation. I used various classification algorithms to train the model and predict species of penguin. So you can see here I have implemented several classifications and with different hyperparameters. And apart from these traditional classifications, I have implemented artificial neural network classification as well. So looking at the accuracy scores, you can see there are best performing classifiers like XGBoost, Decision Tree. However, ANN classification results were not promising as compared to the other classification. So this gives us the idea that the current architecture and the hyperparameters that I have used for ANN need further optimization. So then it will improve the performance on the given dataset. So moving on, so among these best performance, I have selected XGBoost model as the final model for this project. So because it showcases 0.98 uh, accuracy, which is 98.80 accuracy, and in classifying these penguin species. So based on their these performance that I have selected this as my best performing model. So now let's take a closer look at the model performance using confusion metric and classification report. You can see in this confusion matrix, it was perfectly classified with no misclassification for Adelie penguin, where class 1, which is chin strap penguins, had one misclassification, and gender penguins were perfectly classified. And looking at the classification report can get the same idea of the F1 scores and precisions. Uh, if we draw a ROC curve for these classifications, you can see AUC score of 0.99 for class 0, uh, 0.97 for class 1, and 1 for class 2. For this out of sample prediction, I use this data. These are the results that I got. This model predicted this data set to be an Adelie penguin with probability of 69.61. This With this result, we can confidently conclude that our model performed well in predicting penguin species based on their physical attribute. So the XGBoost model stood out as the best performer with impressive results like 98.81 accuracy. So the findings from this project supported my both points of the hypothesis, and this provide a valuable insight into penguin classification. Thank you for watching. Have a good day.